All right, so guys, this is number 11 out of 4.3, and it says find the indicated probabilities using either the geometric, the Poisson distribution, or the binomial distribution. And then it says, then determine if the events are unusual. Use the appropriate probability tables or technology to find the probability. Okay, so the problem here says the mean number of deaths per minute in a country in a recent year was about 3. Find the probability that the number of deaths in any given minute is exactly 5. Part B says at least 5, and Part C says more than 5. All right, so I need to determine whether this is a geometric, a Poisson, or a binomial distribution. The fact that we're talking about an average per unit of time, so it's like the mean number per minute, that's telling me that this is going to be a Poisson distribution because that's how Poisson distributions work. Okay, so we know that the mean is equal to 3. And for part A, we're trying to figure out what's the probability that we have exactly 5. So that's telling me that my x, my random variable, is going to be 5. So when I'm doing this, guys, I'm going to use my calculator, and I'm going to go to the Poisson PDF. And in the first spot, I'm always going to put my average, and in the second spot, I'm going to put my random variable. So in this case, I'm going to put 3 and then 5. So let me walk you through the process and how I'm going to do this on my calculator. So let me grab my calculator app. Let me clear this out. I'm going to go second vars, and I'm going to go down to Poisson PDF, and on my calculator app, it's choice D. Okay, and I'm going to put 3, 5, hit enter, and I'm coming up with 0.1008. So here I'm going to say it's 0.1008. And it's asking me to round to 4 decimal places. That's why I stopped there. I think the number after the 8 was a 1. And to show you, let's see, here's my problem. So I'm actually going to type it into my MATLAB, 0.1008. And, okay, perfect. So we know that it's working, right? Okay, so now let's do part B. Part B says at least 5. So part B says at least 5. Okay, so at least 5, let's think about it, what at least 5 means. At least 5 means 5 or 6 or 7 or 8 or 9, right? And we could keep playing this game for a really, really, really long time. So instead of me using, it's going to be difficult for me to do that because when do I stop, right? So remember, the idea in a probability distribution, the probability always has to add up to 1. So at least 5 would be, let's do it for 5 and for 6 and for 7, right? And we're going to keep playing that game forever. So instead of me doing that, what I can do is I can say, let me find out what's the probability that it's going to be less than 5, right? So let me find the probability for 0, for 1, for 2, for 3, one more, for 4. Let me find this value, and then if I take 1 minus this whole value, then that would leave me with everything else, okay? And so the way that I'm going to find what I have here in the blue is I'm going to use my Poisson, but now I'm going to go CDF, okay? Because I want to add up all of them from 0 all the way to 4. So my average is still 3, and I'm stopping at 4, okay? And then once I find this answer, I'm going to take 1 and I'm going to subtract that answer, okay? So let me walk you through this process again. I'm going to come back to my calculator, and I'm going to go second vars. Now I'm going to do Poisson CDF. It's the last one. It's choice C for me, okay? I'm going to put 3, 4, okay? And now I need to do 1 minus that answer. So I'm going to go 1 minus my answer, and I'm coming up with something like 0.1847. So let me write that down. So for part B, I came up with 0.1847, okay? And I'm going to plug that into my problem right here, 0.1847. And I'm going to check my answer. Okay, so we're doing okay so far. And then part C says more than 5. Okay, so let me do this. Part C says more than 5. Okay, so what does more than 5 mean? Well, it means 6 and 7 and 8 and so on and so forth, right? So I'm going to do this just like I did the part B, right? So I can say, well, look, if I were to take 0 and 1, right, the probability of 2, and all the way up to 5, and if I were to find this value, and then take 1 minus that value, that would leave me with 6, 7, 8, and so on and so forth, right? Okay, so let me do the part here in the blue. So again, I'm going to use my Poisson CDF. Remember, C, because C means cumulative, like you're adding them all up, okay? We said that our average was 3, and I'm stopping here at 5, okay? So I'm going to grab my calculator one more time. I'm going to go second vars. I'm going to go to my Poisson CDF. I'm going to put 3, 5, okay? And then I need to do 1 minus that answer. And I'm coming up with 0.0839. 0.0839 is my overall answer, 839. And I'm going to plug that into my MATLAB right here, 0.0839. And I'm going to check it out. And okay. So now we want to figure out, are any of these events unusual? So it's unusual when my number is smaller than 0.05. And so if you look at the first one is 0.1008, so that's not smaller than 0.05. Part B is 0.1847. No, I need something smaller than 0.05. None of the events are usual. Part C almost, because it's 0.08, it had to be smaller than 0.05. So I'm going to select D, and there we go, right? So guys, this here was number 11 out of 4.3. I hope it helps.